So I'm going to talk to you about how fusion naturally occurs in stars. So let's start from the beginning. Stars start out as nebulae, or one of these singular is called a nebula. And a nebula is made of tons and tons of gas, the most abundant gas in the universe, in fact, hydrogen. Now, what happens is at some point, this nebula destabilizes due to some cosmic level event, and it compresses together due to the force of gravity. Now, what happens is this force of gravity exerts an immense pressure on the gas, which causes temperatures to skyrocket to the point where the matter inside the nebula reaches a state of matter called plasma, where the electrons are literally stripped off of the atoms. So now we're just dealing with the nuclei. So what happens next is these nuclei gain enough energy and momentum to almost barrier right through the electrostatic repulsion that holds them back from each other, because, opposite charges repel each other. But what happens is they're usually not quite strong enough. However, because of the immense energies involved, quantum theory predicts that a particle can actually quantum tunnel through the electrostatic barrier if they get very close and are very energetic, due to the fact that quantum theory predicts that you can't exactly determine the position of a particle and that there's a lot of probability on the events that occur in the universe. So a particle sometimes quantum tunnels, very rarely quantum tunnels, through the electrostatic barrier to perform fusion. However, because this is in a large-scale place like the sun, it's actually common enough to hold back the force of gravity and keep the star from collapsing and dying, at least for a certain amount of time, give or take 10 billion years. Now, how this fusion exactly happens can be detailed through a whiteboard, but unfortunately this phone mirror images everything that it records, so can't really use a whiteboard. So I'm going to try this as best as I can by describing it verbally. So you have two protons, which are hydrogen nuclei, and they collide together. They form a two-proton nucleus, which is unstable. Now, a thing called the weak interaction can actually turn the fundamental particles inside a proton to change the fundamental particles inside a neutron and release some other fundamental particles to make a deuterium atom, which is an atom containing one proton and one neutron. How this happens is the proton decays into a neutron and then takes some energy from the temperature outside and also releases a positron, which is the antimatter equivalent of electron, and a neutrino, which is a very high energy particle which rarely interacts with matter, but is found often with electrons and antimatter electrons. Now, next, what happens to this deuterium is another proton fuses with it to form a helium-3 atom. Two of these helium-3 atoms can fuse to form a helium-4 atom, which exert two extra protons. These two extra protons are converted to pure energy, and due to Einstein's equation, E equals mc squared, two protons multiplied by the speed of light squared is equal to the total energy released, which is a ton of energy per reaction, and this is why it's able to counteract the gravitational force which pulls stars in. So basically, without these nuclear reactions, none of us would be alive, the universe wouldn't be alive. We'd pretty much just be a bunch of drifting quarks and leptons and weird fundamental particles. So, thanks, fusion.